Hey guys, welcome back to another video. We are continuing on with our discussions about sketching parabolas. Now in the previous video we looked at the effect of dilations, the concept of playing around with this coefficient of x squared, this pronumeral a, and what the effect was of making it bigger or smaller. Now today we are looking at reflections here. And you guys may have noticed in the last video, I quite purposely only looked at some positive values of a. We made our parabola narrower by making the a bigger. We made it wider by reducing the size of a. But we never actually delved into the negative numbers. And that's for a very particular reason, because that relates to the idea of another transformation which we are talking about today. This is the idea of a reflection. Now, a reflection may be familiar to some of you if you've watched my videos on geometric transformations. We looked at the idea of a reflection just being a mirror image of an object, a mirror image of the original. Now, if this sounds familiar to you, you may be pretty happy to hear that everything we learnt from there, this idea of a transformation, your knowledge from that is actually going to be applicable to what we are learning today. Now, let's jump straight in. I have an example here which has the same parabola I used in the previous videos, and we're going to look just first off at the effect of, instead of making the coefficient of this x squared 1, which as we have here, what if I made this negative 1? So what if I tried to sketch y equals negative x squared? What would happen there? Now let's find out. As we did before, we are going to just investigate. We're going to play around. We're going to draw up a table of values, and we're just going to see what happens to all of the points. Now, I'm going to pick the same x values that I have in my current graph, and we're going to see what happens. Now, we have to be really careful with this negative in front when we do our calculations. Now, subbing in x equals negative 2 here, I'm going to get negative 2 all squared, which gives me 4, and there is a negative in front here as well. So I'm going to get negative 4 for this one. Subbing in negative 1 squared gives me 1, but I still have this negative in front, so my value is going to be negative 1. For 0, I'm just going to get 0. And for my 1, I'm going to get, well, 1 squared gives me 1, but a negative in front gives me negative 1 again. And 2 squared gives me 4, but I can't neglect the negative, so I get negative 4 here. So let's just draw in these points and see what we come up with. So when x equals negative 2 here, my y is going to, whoops, I don't have many points here. Let's say that's 3 and 4. So my y is going to be negative 4. When x equals negative 1, y equals negative 1 here. When x equals 0, y equals 0 here, so my 0, 0 point, my origin remains. When my y equals 1, x is negative 1, and so on and so forth, down we go, until we reach this thing down here. So I'm going to join up these points, and we're going to see what we get. Okay, that's probably about as good as I can draw it freehand. But if we go back to the idea of reflection, now let me actually just draw the example that I had here. we can see that in my mirror image, everything is in the reverse orientation. And I have my sort of mirror line here. Now have a look at these two parabolas and see if you notice anything peculiar. Let me actually draw in a line here and see if this rings any bells. Now, if you look at this, maybe turn your head to the right or to the left, you will hopefully be able to see that my parabola up here is perfectly mirrored down here. Let's actually do that in a different color to really make this clear. I can see a mirror reflection around my mirror line here in the same way I had up here. So when I actually pop a negative coefficient in front of my x squared, now all I've done here is I haven't actually dilated it. I've kept it as a, instead of a coefficient of 1 here, I've kept it as a coefficient of -1. So that has resulted in the same parabola just reflected, just a mirror image here. Now, as we did before, let's take a closer look at the points and see if those suggest to us something similar. Now, going in and labeling these, I have here -2, -4, -1, -1, -1, -1, oh sorry, +1, -1, and I have +2, -4. Let's look at what is happening here. Taking these points, 4 in my y coordinate when x equals -2, has now been transformed, reflected down to -4. It is the same magnitude but an opposite sign. Look at this here, 1 has been reflected to give me -1, 1 to -1 again, 4 to -4. Each time I'm getting the same number but an opposite sign. And think about when you actually like look into a mirror. You get up in the morning, you brush your teeth, you're looking at yourself in the mirror. Everything, because you're looking there, it appears as an opposite. So some of you may remember if you had like a worded shirt, a worded t-shirt or something, and you looked into a mirror, the words, if you looked at it again from left to right, they would be the other way around. It would be the same thing, just in an opposite orientation, kind of like these shapes over here. They are the same thing, just flipped around. My parabolas are the same thing. It's the same, my transform one's the same as my original, but flipped around. What tells me that it's flipped around is these relationships with the y coordinates. All of them remain the same, just with a different sign. 4, -4, 1, -1, so on and so forth. I will always, when I have a negative coefficient, I will get what is called a reflection. So let's write down what we have just learned. So when we have a negative a, we get a reflection of the original parabola. Okay, and that's what we got here. We had my original parabola, and I reflected it. And that mirror reflection line, this horizontal line here, is the line y equals 0. Or we can call this as well the x-axis. So I can say that my parabola has been reflected along the x-axis. And that is the effect of putting a negative coefficient. Now, let's try one more example. And here we are going to try to sketch a parabola. And this is going to bring together everything we've learnt so far about dilations as well as reflections. So I'm going to copy paste my grid again. And I want us all together to graph y equals negative 3x squared. And I'm going to do this in relation to my graph here, y equals x squared. So you can see the effect of both dilating and reflecting here. Okay, so let's give ourselves some room to work. I want to draw up a table of values again. So, whoops, I have my x, I have my y, and I'm going to draw up all of my x values that I'm going to be working with. So I have my -2 all the way up to +2. Now, if I substitute these in, so putting in -2 as my x, I get -2 squared gives me 4 times -3 gives me -12. -1 squared gives me 1 times that by -3, I get -3. I get 0 here again, because timesing anything by 0 gives me 0. And here I get -3 again. 1 squared gives me 1 times by -3 gives me -3. And I'm going to get -12 again. So I need to draw this a little bit bigger so I can squeeze in this -12. So let's just do that quickly. -3, -4, -5, -6, -7. Okay, let's zoom out so you guys can hopefully see the bigger picture. Okay, so some of you hopefully may already be starting to notice why this is a combination of both. Now we have a negative here, so we can already assume that if I'm looking at my simplest form of a parabola, this guy is going to be something like that. It's going to be reflected because a negative coefficient assumes a reflection. So let's actually write that in here, because oftentimes when you go and do these questions, it helps to at least have a little roadmap in your mind of what you're going to be roughly expecting. So I'm going to expect here a reflection because I have the negative sign in front, and this guy here tells me I'm going to have some kind of dilation. And it's going to be a pretty big dilation because 3 is a little bit bigger than 1. So everything's going to be scaled here by -3. All of these points are going to get scaled by -3. Alright, let's just start graphing these. So I'm going to quickly do these. If you want, pause the video and have a go at doing this slowly on your own. But by now we've had a lot of practice here, so I'm going to just go straight into this. Okay. Hope you're all ready for the dodgiest parabola ever, but let's have a go at this. Okay, good enough. Now, this looks really wonky, I know, but let's have a look at what's actually happening. So if I put in my points here, I have -2, -12, -1, -3. Let's see what's happening. Well, my graph's already looking like what we expected. Our dilation, I have 3, which is bigger than 1, my starting coefficient. So I imagine of here in my first graph. So that tells me that my guy down here, my transformed parabola, is going to be steeper than my original. So we can kind of see that there. So check, that's good. And because of the negative, it's also a reflection. And you can see once again, we are reflecting along the x-axis here. So that means our diagram is looking pretty correct. But let's just check one more thing, right? Because we said that here all of our y values here, from what we've learned in this entire course so far about parabolas, when we do these transformations, my y values are changing. Now here we said that my y should be scaled by a factor of -3. So let's just double check that that's actually happening. So my y value here is 4, and at this same point, at x equals -2, my transformed y value is -12. So if I times 4 by -3, I get -12. So this has in fact been scaled correctly. Scaling 1 by a factor of -3 gives me -3. We get the same thing happening with these zeros here, but I have 1, I'm scaling 1 by -3 again, same thing as before, and I'm scaling 4 by a factor of -3 again. 4 times -3 gives me -12. So that is how we can also sense check our way through these types of questions. Before we even started, we made a little prediction about how it would look. So when we do our table of values, we can check, well, are these values of y making sense within the context of our original parabola? My y equals to x squared, with my a, the coefficient of x squared, being equal to 1. And I can see here each y coordinate is being scaled accordingly, and the drawing that actually comes out is a narrower curve, because this guy down here already looks quite narrower than this. To get a better look at this, you can probably also plug this into Desmos, see what happens. And I also have a reflection happening. I'm reflecting along my x-axis. So I get something that is a mirror image except with a dilation. So mirror image but narrower in this case. Now this is how we can navigate ourselves around these types of dilation and reflection questions when they are combined in one, when we are required to graph a parabola that takes into account both of these transformations. But thank you so much for joining me with these videos, guys, and I will catch you in the next one.